Hey everyone, welcome back to my YouTube channel SummarizedAI. In today's video, we are going to explore inheritance in Python, one of the core concepts of object-oriented programming. If you have ever worked with OOP in Python, you have probably come across the term inheritance. Don't worry, it's actually pretty simple once you see it in action. Let's understand it with a real-world example. Imagine this, every vehicle, whether it's a car, bike, or truck, share some common features. There's something which is common. Can you guess? They can start, they can stop, they have a brand, color, correct? But each type of vehicle also has its own unique features. If you take an example of bike can be restart, okay, and it can be kickstart, sorry. But if you talk about the car can have air conditioning, it can electrically charge, okay, using charging. Wouldn't it be a great if we could reuse those common features instead of writing them again for every vehicle type? So let's take an example. You're writing a code, okay, and you have a class. In that particular class, you have told I have a vehicle, okay, that particular vehicle will get start, stop, accelerate. It has a brand, okay, it has a color, model. But suppose if you are going to create a car or a bike, what is unique for car we just discussed? It is air conditioning, electric charging. This is unique. Okay, and in bike, it's a kickstart. But rest of the things you see, what we discussed earlier, color, model, start, stop, those are common. Correct. So what we can do here is we can create a class as a vehicle and keep all common things related to that in one class. And whatever is unique to car and bike, we can write those functionalities in the respective classes. And we can reuse the vehicle class in car and bike. And this reusing, we call it as inheritance. Okay. And the concept of inheritance is same in all programming languages, but how we write the syntax is different. So let me go ahead, okay, to my next slide. First, we will discuss about how many types of inheritance we have. Then we will proceed to the single inheritance. So we have these types of inheritance: single inheritance, multi-level inheritance, hierarchical inheritance, multiple inheritance, hybrid inheritance. Hybrid inheritance is nothing but the combination of these four inheritance. Okay, either it may be single multi-level or single multiple. Yep. Now let's go ahead and start single inheritance. So we just discussed whatever common functionalities we have, we will keep in the vehicle class. Okay, and whatever unique functionalities we have for car or bike, we can keep this in one class. Okay, and we will create a relation in between these two classes, which is nothing but inheritance, to reuse the methods and the attributes of this class so that we need not to write this particular code again in car class. Great, excellent. Now let's go back to our Visual Studio, and here let's create a file single.py, single inheritance. Okay, now in this particular file we will see how we can write the classes. Okay, how we can write the single inheritance syntactically in Python. Okay, so first what we need here is, first we need a vehicle class. Okay, and this particular vehicle class is going to have all its respective properties, or I would say features or actions. Okay, now let's see vehicle and def. Let me create a constructor, and if you want to read or know more about the constructor, you can go and check my earlier videos. I have created a detailed video on constructor. Okay, now brand. Let's initialize this variable here. Brand equals to brand. Don't worry. Once I'm done writing code, I will be explaining things to you. Now we have created a constructor. In this constructor, we are initializing a variable, okay, and assigning the value brand so that it will be a class level variable. Now let's create a function. So we just discussed we can have start function and we can stop also. So let's first write start function. So print and type here self dot brand. Okay, vehicle started. Okay, this we have created a start function which will allow us to start the vehicle. Okay, now let's write one more function as stop. Here we are saying vehicle stopped. Now in this particular vehicle, we may have some more functions like steering or accelerate. Okay, but I'm just taking an example of two functions. Let's go ahead and create a car class. So here we are seeing we have created this class having these functions. Now let's create a car class and inherit this vehicle class. Let's see like how it works. So we are saying class car, okay, and it is inheriting vehicle, correct? So this is how we can create the inheritance in between two classes. Now here the car class is a child class of this. This is a parent and child class is inheriting whatever parent is having. Okay, great. Now here also we will create the constructor. Okay, let me copy this constructor from there to here. I do not wish to rewrite this code again. And here I'm just creating a car specific property. For example, model I have created. Okay. Now here in place of writing self, I will be writing super. Okay. Dot underscore underscore init. And in that function, I will be calling this brand and then, yep, brand I'll be calling. Yeah. Now what it will do as soon as we create an object of the car, it will call this particular constructor and this constructor will be calling the parent class construction and will initialize the brand. Because brand is public, we will be able to access this particular brand in the child class also. This we will see. Now, as we discussed earlier, let me first initialize the model also because I have given a variable name model here. Okay. Now we have discussed we are going to have a function which will say display, okay, or charging, anything is fine. So we will create a display. Now, after creating this function, let's give the definition to this particular function. We are saying print, this is a, I can say self dot brand, okay, and I can say model also, self dot model car, okay. This is a display for this. Now, let me quickly go ahead and create an object of this car. So car equal to car, and here I'm passing Tesla, okay, and I'm passing here model, which is Y, okay. Now let me go ahead and call this particular method here, display, okay. Now, as soon as I run this particular code, sorry, we are getting some error here. Super object has no attribute. Car dot, oh my God, sorry, this is the one. I forgot the underscore. Good. Let me clear the console quickly and rerun this code. Yep. So now if you see here, we got the output. This is display for Tesla model as by car. Okay. Now you see, because we inherited this particular vehicle class, which means we can access its variable, access the attributes in the child class. That's what we are able to do. Now we have this function here, start stop. Okay. Now what I can do here, I can start my car and I can stop my car. Start and then stop. Now you would see I'm able to start my car, I'm able to stop my car, but I did not define anywhere in my class start and stop correct functionalities. But because we have inheritance is enabled, that's where we are able to access this particular start stop. Now suppose if I break this inheritance, okay, see what will happen. It will give the error for this one. Let me do one thing. Let me remove this constructor for time being. Now let me rerun and you will see it will say like this particular function is not defined. Okay, see. It is saying car object has no attribute start. Okay, it gave the error. Now, if I go ahead and write vehicle here back, just writing this keyword here, the class name or the inheritance. If I run this code, yep, it is showing brand is not there, but I'm able to access the method. Okay. Now, if I define the constructor again, okay, here, and now try to access this, you see, I'm able to access. The car started, stopped. Okay, and if we have another functionality also of the vehicle, I can do that. Similar to that, if I will create a bike, just replace it with the bike and this with the kickstart, I will be able to write everything about the bike in this particular class. Okay, and this is nothing but single inheritance where we have one-to-one mapping. Okay, now if we move further, and I'm sorry I'm going in detail because I want you guys to understand how this inheritance works end to end. I would have, wrote the code earlier and could have, just explained you the code, which will not help to get the detail out of it. But yeah, let me go to my next slide. It's a multi-level inheritance. Single inheritance was class vehicle and the car. But now what we are saying is I have a class vehicle, it has a start stop. I have a car which has a display. Now I have a car Tesla. From this particular car vehicle, I will be creating a Tesla. Okay. So I'm saying I have a class Tesla. Okay. And which is having a car as an inheritance. Now the same thing if I copy from here to here. Okay. If I copy from here to here, now here I have a model and I'm going to create a variable like electric. Okay, just an electric, and it will take like um, uh, Boolean. Okay, true or false. Electric. It is electric or not. It will take that. Now here I'm saying super in place of super. I would be saying now vehicle. Okay, so vehicle will take the brand. Okay, and if I copy paste this thing here again, I have a car. Car will take the model. Now I have electric. It will take the electric. Okay. Now this is done. Now I have defined my constructor. Now let me go ahead and define one function which says charging. Okay. Charging. And here I am providing self and let me write print statement and which should say charging charging is there. Okay. And I would say self dot electric. So it will say yes or no. Okay. Now we got this thing here and let me format this string also here. Now if I go back and create an object quickly of Tesla, Tesla equal to TESLA Tesla, and then Tesla is expecting three parameters here, three arguments, I would say. The very first argument is brand name. Then we have model name, which is Y. And then we are saying, is it electric or not? Yes, it is electric, boss. Now, if I go ahead and say Tesla dot, okay, Tesla dot charging, okay. If I call this particular function, let's see what happens. Okay, let me clear things here. Let's call this function. It is saying vehicle dot underscore underscore init and the brand. So what it is saying, vehicle, oh yeah, not the vehicle, sorry. I have to, so what I'm doing here is I'm calling a super. So I have to just call a super because it's a multi-level inheritance. So if I call the super, it will call this one and this super will call this one. Okay. So this super is already calling the parent. So I have to also call the super to call that one. So here I'm saying super and in this super, I'm passing my brand and the model. Okay, this is not required. And I required the bracket for the super. Great. Now let me clear. Let's go ahead. If you see, it is saying charging is there, true. Okay, I passed. It called a function. Now you see in Tesla, I have written this much of code. Okay, and suppose this one code is like written by third party or some other team member. What I can do here is, because I have an inheritance enabled, I can simply go ahead and write Tesla dot start, Tesla dot stop. Okay, I will be able to consume those functionality. Now Tesla dot display. Okay, and charging, I will move it to last. Why? Because in sequence it will look good. So now you see my Tesla is able to start, is able to stop. It has a charging, okay, and it has a display also, and it has a charging also. So all these things, like what we wrote in our class, it's like 5 lines of code, but what it got us like 10 or 15 lines, correct? This vehicle, whatever we have written, it it gone to car, then from car it came to Tesla. It is something, if you see, it is a grandfather, okay? From grandfather, the things got transferred to father. Father inherited everything from grandfather. And then again, father transferred those things to son, which means son is inheriting things from father, and father is inheriting from grandfather. And at the end of the day, if you see, son is indirectly inheriting things from grandfather. Correct? Yep. So this is nothing but multiple inheritance. Now let's move further and talk about hierarchical inheritance. Hierarchical inheritance is nothing but for first I will take an example from family. So here we have a father and father has two kids. Okay. And two kids are inheriting everything from their father. Okay. So this is nothing but hierarchical inheritance. So similar to this in case of vehicle also. Vehicle, what we discussed earlier, is car, truck, bike. These are nothing but hierarchical inheritance. It has a hierarchical relationship with the parent. Okay. So here we have only one parent as vehicle, and vehicle has two child. Okay. Car and bike, because car and bike got created from vehicle. Okay. Or inheriting things from vehicle. Okay. Great. Now let's go back to our code and try to develop this thing. Now let me go ahead and duplicate this file. So let me copy and then paste again. And here, let me say hierarchical. Okay. Now let me remove everything here. Okay. Let's remove everything till here. Now you saw earlier we had vehicle, start, stop. We had car, which has a display. Now what I'm gonna do here is I will just copy this car class. Okay. And I will create a bike. And as we discussed earlier here, bike is inheriting vehicle. Okay. So bike is inheriting vehicle. Okay. And bike is going to have a brand and the model, which is correct. And in place of display, bike is having kick start. Okay. So it is having a start. Great. Bike is kicked start. Okay. And let me say the model and all. This is fine. Now, if I go ahead and again create a car object here, this is what we saw earlier. Okay. And if I say car dot start, car dot stop, okay, my car will be able to start and stop, and my car is also having a display. Cool. Now this is like all about car. If I run this particular piece of code, it should be it is showing an error. What it is saying, car dot init should be having only one parameter. Um, Passing line number 28. Oh yeah, I forgot to pass the parameter. So here it is like car head Tesla. Car is Tesla, and here I'm passing the model as Y. Okay. Now let me go ahead, clear my screen or the console. See, Tesla vehicle started, Tesla vehicle stopped, model. Okay. Now let me copy this code, paste it below. Say bike, bike, and here I'm saying bike. Okay. Now bike is having Honda, okay, and it is having a ABC model, okay, ABC model, some model is there. Now, if I try to run this code, it will say, um, sorry, I have to update the object also because this object will call this method. Done, and let me give a print here also so that we can differentiate. Great, cool. Now you see for bike.kickstart, oh, bike is having a kickstart method. This is the different. So you see here we created an object of car, we created a car, and car is referencing to or inheriting vehicle. So vehicle is having a start stop and car is having its own method display. So similar to that, bike is also inheriting vehicle and vehicle is having a start stop method. And here we have a very specific method kickstart with respect to bike. Okay. Now if I try to run this particular piece of code, you would see we got the output Tesla vehicle started, stopped, and then model. Same to this, we have Honda vehicle started, stopped, and then bike is kicked start, Honda ABC. Okay, so this is nothing but hierarchical inheritance where two different classes, okay, inheriting the same class. That's it. Now let's go to the next, which is multiple inheritance. So you saw here two different classes were inheriting one class vehicle, but it is different here. It is one class inheriting two different classes, which means my father is having something and my mother is having, okay, but combinedly, um, their kids got everything, okay, something like that. So if you see, we have a class car is having a display method, but on the other hand, we have an electric vehicle. So electric vehicle will have a charging. So now if Tesla is going to create a car, what they gonna do? They gonna have autopilot. Okay, so they are saying like we are going to release a new car. This car is having only one thing changed, which is the autopilot. Okay, can we create a new car, new model? Yeah, we can do that because whatever functionality we had from earlier cars, we can inherit those properties or of those classes, sorry, so that we can get all the methods and attributes. So he will go ahead, Elon Musk will go ahead and import this or inherit this car class and vehicle class so that it will get start, stop, display, accelerate, and from electric vehicle it will get the things related to the charging. So now at the end of the day, it is having a car which is an autopilot car getting electrically charged and having all the functionalities from car also. Cool. Now let's go ahead and see how we can implement the multiple inheritance. Okay, so I will go ahead and create a new file, multiple.py. Okay, now in this multiple.py, I will be creating a class car, and again we will be defining a constructor to initialize the variable self, comma brand. Same thing. What we did earlier, we are doing the same thing here. So self dot brand equal to brand. Okay, and now let's create a method also here once the construction creation is done. So def, then you can say display, okay, and then here in display you are going to pass self, and you can say print. This is a display for this brand. Okay, cool. This we have created here. Now let's create an electric car quickly. So I'm saying here electric car. Okay, and here I'm just going to pass model. Okay, so it is model, 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 model. Okay, so now I created a electric car class here, created a constructor which is taking initializing a model. Okay, and here I'm saying charger. Okay, so it will charge that particular car. So I'm saying this is a car self dot brand and model equals to, I'm saying. self dot model. Okay, this is done. Now, this is what we discussed. Now we have both the classes. We have electric vehicle class, we have car class. Now we have to create a Tesla class out of both. Now we will go back, and what we gonna do here is we gonna create a class which we will say Tesla. Okay, and here we are going to pass car, comma, electric car. Now after this, let me go ahead and create a constructor. So I would be saying dev underscore underscore init, and then here I am going to pass self brand model, and I'm going to say electric or autopilot. Yeah, I say autopilot pilot. Okay, just a variable for the autopilot. Now this is done. Now we know this brand refers refers from car class, and model refers from electric car. So we to reinitialize those, what we're gonna do here is we are going to say car dot underscore underscore init. Okay, and then here again I'm going to say self comma brand. Okay. Now similar thing we are going to do for the electric car dot underscore underscore init. Now here I'm going to pass the same thing, which is model. Okay. Now let me reinitialize my autopilot, which I am going to pass it as Boolean. Okay, great. Now this is done. Construction creation is done. Now I'm going to create a function which is autopilot. Okay. Now this autopilot function will have a self as a parameter, and here I'm gonna say print. This is autopilot car. It will say yes or no. Okay. This is, I would say, car name here. Self dot brand. Okay. Let's format this one. Say this, and here you say self dot autopilot. Okay. Now this is done. Now what I'm gonna do here is I'm gonna create a Tesla class object, and here I'm going to say Tesla model Y, and then true. This is the autopilot. Okay. Now if I call this function of Tesla autopilot, you will see some things. Okay. Tesla dot autopilot. Autopilot is there. Bool. Okay. Bool is required. Bool we have already called. Bool object is not callable. Self dot autopilot. Okay. Autopilot true. Autopilot here and there. Self dot autopilot. Okay. Autopilot method. Let me write something like this here. Let's see. It should not be matter, but let's see once. Yep, it was coinciding this name. So now if you see here, our function got called, method got called. So what we did, we created an object of Tesla. Okay. Now we are referring here Tesla class, and Tesla class we passed brand, model, and autopilot. Correct. Now because we are having an inheritance with car and electric car, we will be able to access both brand and the model also here. Let me show it to you because we have a inheritance enabled. Okay. So Tesla with the model Y, autopilot car equal to true. Yes. Now you see from both the classes car and electric car, we are able to use the attributes. Now if I go ahead and call the other methods like Tesla dot display, or I would say Tesla dot charger. See, we are able to call this particular method. So in this call, we have just written the functionality, whatever we have required, the autopilot for Tesla. But because Tesla is electric car, we got this electric car functionality from this class. And this is a car. car is having its own functionalities. What we discussed is start, stop, accelerate, or display. We got it from here. And this is nothing but hierarchical inheritance. Sorry, multiple inheritance. Okay. So multiple inheritance again is inheriting two or more than two classes. Here we have car, electric vehicle. We can have more classes here. So we can comma separate here, and we can have some more class here like autopilot class, I can say. Okay, or I can say some ABC class. Multiple classes we can inherit here. So it's a multiple inheritance. Now, because we are talking about multiple inheritance, I have a use case which I wish to discuss quickly. Now, suppose I have a display method here, okay, or let me create a show method. Show method, okay, self, and I will print this particular show from car, okay, and I will copy this method, same method, and I will create this method here in the electric car also, and it will say electric car, okay. Now let me create this method again below in the Tesla class also, okay. So I have this method in all the classes. Now let me call this particular method Tesla dot show. Okay. Now you see, as soon as I say Tesla dot show, it will call the method which we have in Tesla, which means if we have any method available in the local class, that particular method or the attribute will take the priority. Okay. Suppose I don't have this method here. I don't have this method here, and if I run this code, you see car, it is going to car. So for sure, if this method is not there, it will look for in the inheritance. If car or electric car is having this method, so car is having this method. But the only question is why it went to the car, why it did not go to the electric car. This is where, or let me change the sequence to show you. Okay. Now, if I change the sequence, you will see it is now calling the electric car, which means the sequence of classes in the multiple inheritance matters. So whichever is class is first, that particular class will take the priority. Okay. Now, if I have one more class ABC, and if we don't have this particular show method in both electric car or car, it will go ABC, which means it is traversing from left to right. And this is nothing but MRO, method resolution order, which Python follows. And that's because of MRO, we don't have diamond problem. Okay, so the diamond problem is something when you have a multiple inheritance and how this particular Tesla class will decide which class method we have to call, because show method is available on all the classes. So whichever, so in case of Python, that particular diamond problem is not there because MRO is there, and MRO tells whichever class in the left first will take the priority. If it has that particular method, it's good. If not, then it will go to the next one, then next one, then go so on. Okay. So I have already created a video, very detailed video in MRO. You can go ahead and check. And one more point I wish to add, we can customize the MRO also. So if I have given the sequence and if I have a show method in electric car and in car also, I can give the prior to the car. I can customize that MRO sequence. Yep. Go ahead and check out that particular video. This will provide you the detail of MRO. Okay. Now, this was all about multiple inheritance. Now, the last one is the hybrid inheritance. Okay, that's the last one what we discussed. And hybrid inheritance is nothing but I already told you it is the combination of one or more inheritance. So this is the one. So this is the one. And if you see this particular inheritance, if you see this vehicle and car, it is a single inheritance. If you take these two only, if you take these two only the single inheritance, if you see these two only single, these two single. Okay. Now here Tesla is having a multiple inheritance with car and electric car. Correct. Now, if you see this vehicle, this is hierarchical inheritance. So these two classes inheriting this one. Okay. And the last is multi-level. So we have vehicle, then we have car, and then we have Tesla. So this is the perfect example of hybrid inheritance where we see all the inheritances. Okay. Now let me go ahead and do one thing here. Let me go ahead and remove this. This is also an example of hybrid inheritance because here we have two inheritance. We have single label inheritance and multiple inheritance. So two inheritance, which we call it hybrid. Okay. Now this hybrid inheritance, it is the same thing. Let's go ahead and implement. Okay, but before that, the MRO what we discussed, it gets applied here also. So if you have a method show here, 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 and here, this will take the priority first, the Tesla show method. Then it will go to the car, then it will go to electric car. If these two are not having, so if suppose electric car is not having, then it will go to the vehicle also. Okay, so this is how it will resolve that particular show method and how MRO works. Now let's see the implementation of hybrid. Let's go ahead and go back to our Visual Studio. I have already created a file hybrid.py. Okay, and here I'm seeing we have a vehicle method having move as a method. Okay, so let's go ahead and start. So as you know, we will be defining a class first. Let's declare vehicle. Now after that, in vehicle method, we require a constructor. Okay, so underscore underscore init underscore underscore, and then here we are going to say self comma brand. Okay, now print. Here we can say, not the print, I don't require, I will be just initializing the variable here. So self dot brand equal to brand. Okay, done. Now we will create a function. So what we saw here is we are going to have a move function here. Okay, so let's create a move. So def move, and then here we can pass self and then say print, and then I can say I'd move, and I can say here self dot brand. Okay, and let me format it. This there we have created the vehicle class. Now you can see here vehicle class got inherited by car and the electric car. Let's create those classes also. And what I'm gonna do here is I'm going to go in my multiple inheritance. Let me get both the cars from here in place of creating it again. So I go ahead, copy, paste. I have a class as car. Okay, and this particular class car is inheriting the vehicle. Okay, now in this we have this particular constructor. Okay, in this particular constructor we are passing the brand, and brand is nothing but we have to pass this brand on the parent class. So init dot super dot underscore underscore init, and then pass this particular brand there. Okay, good. Now once we have this, we are able to inherit. Okay, now in the car class what we saw, we have start method. Okay, so what I'm gonna do here is I'm gonna change this to start. Done. Now this is done. Like start, we can have stop also for the car. Okay, no problem. Now once we have the start, we have car class ready. Now we are going to electric car. Okay, and electric car, if we see, is inheriting vehicle. So let me go ahead and inherit vehicle here. Now as soon as I do that, I need the same thing here also because it's an inheritance. Okay, now if I go back here, it is saying charge. I'm already having that function. I'm not going to rewrite it. Now in place of model, I wish to have a brand here. Now this is done. No model, only brand. Great. Now electric car is ready. Now what we're gonna do here is we are we require a Tesla. Okay, so we create a Tesla. So let's create a car class Tesla. So Tesla, I can get it from here. So I already created, which is implementing this autopilot thing. So let's go here, copy this whole thing and come to hybrid. So here, if you see, we have a Tesla inheriting car and electric car. So let me move this first. Okay, now apart from this, let let the model be there. So I'm saying car.init. So what we are saying here is we just require to pass the brand. Okay. So what I can do here is I can say super. Okay. Let's try with the super, how it behaves. Super.init, and here we're gonna pass brand. Okay. Now apart from this one, let's remove, and you can say brand, not brand, model. First to model. Okay. Now in our electric car, we have this super dot brand. Yeah, this is fine. Now model is there. In place of autopilot, I said like, yeah, I will have autopilot method. Good. Now brand is there, model is there. This I don't require. Okay, great. Now I created a Tesla object, and this Tesla object is having only brand and model. Okay, and I don't require this particular argument here. Now if I call start move method from vehicle, start method from car, and charge method from here. So move method. So let me first call move. So I'm gonna say Tesla dot move. Okay. And then after Tesla dot move, I have a start method in car. So Tesla dot start. Okay. We call both the methods. Now apart from this, in the electric car, we have charger method. Tesla dot charger. Okay. Now we have the last method, which is nothing but autopilot method. Cool, done. Now let's go ahead and clear the console. And now you can see here, we are able to access the method from vehicle class, the move, okay, and the attribute also. And then we created a car class. Okay, in this particular car class, we have a start method. We are able to move it. And similarly from electric car, electric charge or car, we have charger method. And in the autopilot, in the test class, we have created an autopilot method. So from every class, we have one of the method we are able to call. Now, if you see here in the hybrid inheritance, correct, I wrote only 5 lines of code again, but I'm able to call these many functions and functionalities. Okay, I do understand I have kept only 1 line of code here, but in the real world, you will be having lot many lines of code here. So only 5 lines calling lot many lines of code. And this is nothing but the reusability. So using inheritance, the very first thing what we got is the reusability. Great. Now let's try to understand. So this was all about inheritance, by the way. Okay. And now let's try to understand uh, what are the advantages of inheritance? Why do we need inheritance on the first place? The very first thing is it promotes code reusability by sharing attributes and methods across the classes. This is what we saw. Across the classes, we are able to share the methods and the attributes. Second thing is we can create real world hierarchies and relations like father, son, grandfather. Correct. The second one is animal, dog, animal, cat, and we have different types of cats also. Okay. And if their characteristics, their actions, now how they bark, okay, how they eat, it's different. Now, if you talk about person, we can have person as an employee. We can have, if you take a human, human can be employee, human can be a user, okay, or human can be a student. So these are the different relations we can create. Now, apart from this one, the third is it allows us to override methods to customize subclass behavior. Okay. Now, if you see, we have a method start here in the car class. Okay. So here we have written like start the car by key. Okay. But in my latest car, Tesla, what I'm saying, as soon as I enter in my car, okay, and I press button, it should get start. I can override this particular functionality here. And this is what we saw when we were talking about MRO. So it's nothing but the function overriding. Okay. So if we have a function in Tesla class, that function will take a priority because we overrided that particular function. If this is not there, then whichever class is having using MRO, that particular function will get called. Great. Now the very last is it allow us to develop scalable and extensible design with the help of polymorphism, which is nothing function overriding. Correct? We just discussed. And this is all we have for today. I hope you liked this video and I tried to explain as much as and as many as things as possible. Okay. If you found this video helpful and want to see more video on Python on AI, don't forget to like and click on notification bell icon to stay updated and subscribe to the channel. See you in the next video. Till then, bye bye.